Hello and welcome everybody to our webinar, Maximizing Plastics Packaging Recovery. My name is Michelle Wiemer. I'm in charge of communications at TOMRA Recycling and your host for today. In the next 45 minutes, you will get an introduction to plastics packaging in general, followed by two presentations of two of our product managers, Philipp Knopp and Johannes Jacobi, who are going to explain us more about the solutions available to increase plastics packaging recovery by using advanced technologies and data-driven approaches. Some general information up front before we start. You're all muted, so no one hears or sees you. The session is recorded, so in case you can't join and stay until the end, don't worry, the recordings will find their way into your inbox in the next days. We will present a lot of information to you. This in turn will trigger questions on your end. You have the chance to post all the questions that might arise in the chat box on the right-hand side of your desktop. We are going to pick them up later in our closing Q&A session and provide all the answers you needed. Last but not least, we will do further webinars and would like to improve our webinar performance and experience for you. So before we close the webinar, a short survey will pop up on your screen, and we would highly appreciate if you could stay 1 or 2 minutes longer to provide us feedback. With that out of the way, I think we can start with a short introduction into the topic. Well, plastics packaging. Plastics packaging is actually all around us, whether it's your beloved cream cheese, delicious chocolate, a shampoo bottle, or the currently, unfortunately, indispensable hand sanitizers. It is all packed in lightweight, durable, and protective plastics packaging, bringing a lot of convenience for us. But what's convenient for us is less welcoming in and for the environment, for the planet, and our valuable resources. If the plastics packaging is not designed for recycling, properly disposed of, collected, sorted, and recycled. Speaking of recycling, do you know how much plastics packaging is currently being recycled in closed loop per year? Let's do a quick poll for about 10 seconds. Okay, I'm curious to see the results. I have 3 more seconds for you. Oh, thank you very much for the participation. This is a rather fragmented picture, but we clearly see here that we are talking to experts. To resolve the poll, only 3% of plastics packaging produced annually is recycled in a closed loop, which means that once recycled, they are used for the production of the same products. These 3% also indicates that our shampoo bottle, our cream cheese pack, and all the plastics packaging come with a high environmental price tag, and it's calling for clear action. At TOMRA, we are dedicated to enabling greater sustainability and making recycling commonplace. In fact, we are practicing circular waste management for 50 years already. Currently, we have more than 4,000 employees working across 4 business streams, as well as a circular economy division to provide technology-led solutions that optimize the recovery and reuse of resources in the recycling, the mining, the food, as well as the collection industry. Combined with our impact leadership and cross-value chain collaboration, we are working on and we are finding solutions for today's and tomorrow's challenges. Now, I guess I have talked real lot about the challenges and it's time to come to solutions. This being said, I'd like to leave the stage to Philipp Knopp, our first speakers, who will present us the solutions available at TOMRA to maximize plastics packaging recovery. Philipp, the stage is yours.
Hello, and thank you, Michelle. So my name is Philipp Knopp. I'm working since almost 10 years for TOMRA Recycling, and I'm working as a product manager and responsible for the AUTOSORT product portfolio. Let's go into the presentation. So first of all, world plastic production, what does it mean? So polymers are one of the most important raw materials for us in the worldwide. So the global production increased from year to year, and it will be expected to triple that in the next 40 years. So in 2021, we see that we almost had a production of 360 million tons of polymers, but only 30% will be recycled at all. Round about 50 million tons, this is the total European plastic converter demand, is split in different segments. And if you have a look on the top of the segment, we are talking about 40% going into the packaging. So packaging has the greatest demand of the polymers. So if we're talking about package recycling, so there are several different possibilities to sort individual fractions, but the main polymers when we talk about package sorting is polypropylene, polyethylene, PET, and also PS. You are probably familiar with the graphics from Ellen MacArthur Foundation. So the numbers are not really up to date, but the overall message are still valid. So the way plastics will be treated is more a linear economy than a circular economy, which we are aiming for. So in the process loop on top of these graphics, you see that actually 14% plastics will be collected and only 3% of them going into a closed loop. And this is more or less or mainly the PET material. 10% of other polymers and also PET going into the cascade recycling. So will be recycled, but more or less also downgraded. If you have a look on the right-hand side where we see the arrows, then we see 40% goes into the incineration, so will be burned. 40% goes into the landfill, and 32% going into leakage, so direct in our environment. And TOMRA's ambitions are 40% collection for recycling and 30% closed loop recycling. This is what we are aiming for. Which trends do we see regarding circular economy or on recycling for our business? So first of all, legislation. So there's a pressure on producers of recycling products. So as an example, we have now a change of the measuring method. Before, the output of a sorting plant was counted as recycling material. Today, the output of a recycling plant is counted as recycling material, so the washed flake. So in principle, the legislation is setting certain targets on recycling, which means that our customers has to do this recycling to reach the targets from the legislation. Next point is higher product specifications. So we see it in our projects that the complexity of sorting is increasing, and also the expectations from our customers, what they need. They need a higher purity and also higher yield of the different fractions. Next point is higher quality recycling. So we have a consumer awareness. So they are paying attention to the use of recycling material in the products they are buying. And on the other hand, we have the brand owner, which committed to use a certain amount of recycling material in their products. So, and this high recycling for PP, PS, and PE needs the same sorting sharpness, which is required for PET. The next point, larger sorting layouts. So this is definitely what we see as a trend in our projects. We see that we have now a lot of more optical sorters in one plant. So projects around 35 to 45 optical sorters in one sorting plant to achieve the required sorting accuracy. This is needed. And last but not least, very important part is the digitalization. So the customer or the plant operator needs process information to optimize the sorting process. So not only the performance of an optical sorter is important, it's also how the process is controlled. And to ensure an optimal sorting results, the operator needs process information. And digitalization of a plant plays an important role of that. So to meet the high expectations, customer expectations, trends, and also market requirements, we generated or we developed the new generation of an AutoSort. So AutoSort is TOMRA's multifunctional sorting system, which combines several sensors with the latest generation of flying beam. So the compact design of that AutoSort is designed to integrate into new plants and also for the retrofit where the customer wants to upgrade his process. AutoSort with the design is AutoSort can be used in a wide range of applications such as paper, industrial waste, or also in packaging. We would like to present you now a video which we carry out with our customer MASOTINA. Please enjoy.
Siamo all'impianto di selezione di Corsico. All'interno di questo impianto la società si occupa di selezionare la raccolta differenziata di matrice plastica e multimateriale proveniente dal circuito urbano. TOMRA è stato scelto come fornitore per l'ottimo livello tecnologico e il livello di affidabilità. In questi anni si è dimostrato un valido partner, costante sviluppo tecnologico e di prodotto nella selezione ottica che noi utilizziamo.
La configurazione impiantistica attuale tratta fino a 250.000 tonnellate di rifiuti per la selezione e si articola su 3 linee principali per ottenere dei prodotti suddivisi per polimero e per colore.
Abbiamo stabilito un contratto di manutenzione con TOMRA. Siamo contenti della tempestività degli interventi e dell'efficacia degli stessi, della preparazione dei tecnici che rappresentano per noi, più che un fornitore, un vero e proprio partner nel quotidiano andamento dell'attività.
Abbiamo recentemente sostituito 4 AutoSort con la nuova generazione, in quanto offre la possibilità di istruire la macchina in modo più avanzato. Abbiamo dedicato AutoSort alla selezione del VPET. Ci ha consentito un incremento di resa e aumentata la precisione della macchina nella selezione.
Abbiamo la pretesa che questo lavoro diventi totalmente industriale. Siamo con TOMRA alla costante ricerca di aggiornamento dei nostri sistemi, approfittando anche della formula molto flessibile di fornitura delle macchine da parte della società. L'economia circolare non è una scelta ma una necessità. La materia prima seconda derivante dal rifiuto dovrà essere la base per uno sviluppo sostenibile dell'industria. Su TOMRA ho una sola opinione, lo consiglio a tutti gli operatori.
So I like that video. So the project with MASOTINA, that was very important for us, and it was also a very successful project for TOMRA. So the customer was very satisfied with his previous generation of AutoSort, and then he was also able to run a successful sorting process with also a successful business case. So MASOTINA is very future oriented and trust TOMRA that we are able to improve also these sorting results with our new generation of AutoSort. So the sorting plant was upgraded in the area of PET, and here we had, that was very interesting for us, the direct comparison between the previous and the new generation. And here we saw that the significant increase of efficiency and also the very good feedback from our customer MASOTINA showed us that the AutoSort brings value to the sorting process of MASOTINA. So here in that case, we could increase the purity of the PET fractions around 2 to 3% and also increase the yield of these PET fractions. So we saw that we optimized the process at MASOTINA, and also we had an improve of the business model for MASOTINA. The reason for that is that we used a new generation of AutoSort with a new flying beam technology in combination with SharpEye. So, and this combination allows us to get more information from the material, and we can also distinguish better between objects where the spectra course is very similar. So with this combination, flying beam and SharpEye, we can increase our sorting sharpness to improve the sorting. In addition to that, we have the possibility to monitor the illumination and also the sensors. So this ensures that we can have a consistent performance available, and on the other hand, we can provide the operator much more insights of the sorting process. AutoSort has a modular approach, so you can configure it to your needs. You can also upgrade it at the later stage to extend the lifetime of it when your requirements, or if your input materials change. So we have several sensors, but I want to show you two sensors out of that. So one is the deep laser. It's a laser add-on which allows us to do shape sorting, and on the other hand also the detection of black polymers. With the detection of the black polymers, you can also optimize your sorting process. So you can choose if you want to sort positive on your target fraction or positive on all impurities, because now you are able to detect also the limits which we have in the traditional NIR technology. And the next point is GAIN. So GAIN is our deep learning solution. So we developed this add-on for complex sorting tasks where we cannot use our traditional technology because the traditional technology is under limits. So in that case, I want to show you an example of the silicon cartridge. So the silicon cartridge has to be removed because that has very negative influences in the following sorting steps in the flake sorting area. So in that case, we had several approaches to do that with NIR technology, but then we tried it with shape sorting. With shape sorting, it was possible to sort the silicon cartridge out, but we generate a high over sorting of other PE products which has more or less a similar shape. So and then we try to generate a deep learning solution. So a specified sorting network which is optimized for these sorting tasks to identify the silicon cartridges and sort them correctly out of the PE stream to first of all to sort everything out, and on the other hand to reduce the oversorting. What we saw also where we generate this neural network is there are several possibilities on the area of packaging where we can use this new technology to improve also other applications. Last but not least, process information. So sorting is a complex interaction between different aggregates. So in each process step generates information. You need a tool to collect all this information and transfer these information into process information. So thank you very much, and I would like to hand over to Michelle.
Thank you very much, Philip, for your overview. For what we have seen now is that sensor-based sorting already brings a lot of benefits, but we can do more to boost plant performance. One way to do so is following a more digital approach. And we wondered how much importance you already attach to digitalization in your organization. Let us know by answering one more question. let's say 2 more seconds. Okay, that's a very clear picture and we're glad to see this. However, I would now like to introduce Johannes Jacobi, who is going to tell us more or provide more details by explaining how we connect to even more possibilities by unleashing the power of data. Enjoy the presentation, and Johannes, the stage is yours.
Hi, Michelle, and hi, everyone else. Thank you. As Michelle stated, my name is Johannes. I'm the product manager digital in the recycling business stream, and my responsibility is the overall digital transformation. With that, I would like to jump into the presentation. So as you all, or not all of you, but most of you stated, digitalization is a very important topic. But if you talk about the digital transformation or digitalization in general, it's a journey. And mostly you like to talk about the fun stuff like predictive maintenance, adaptive sorting, autonomous optimization. However, there is a process before that. Like the automotive industry, it has been a long time since they talk about autonomous driving, but we still don't see these cars on the road. So you need to start somewhere. You need to start to walk and build up velocity. So first you visualize the data, then you stabilize the data, build up the velocity. And if you have this stable system, you can actually jump into the future and jump into these exciting topics around predictive maintenance, etc. So you might ask yourself where we are at the moment, where we as TOMRA see ourselves and why we are talking about it now. So we are confident that we are at the edge of optimization. We have the first successful projects with our customers where we see positive results, where we improve their process based on the data that we collect from our machines. Nevertheless, the steps of visualization and stabilization are not finished yet, and it's a continuous effort there. Another topic that Philip already started with is circular economy. It's actually a journey as well. You talk about the jump step. You talk about having 30, or we talk about having 30% in closed loop. But we need to start somewhere. We need to start to walk, and we need to stabilize the system. And one part of that is having more transparency in the overall industry. So if you think about what you throw away, so what you saw in the videos, the yellow bags or the yellow bins or whatever it looks like in your country, it's a very heterogeneous material. And in this waste sorting, we reduce the complexity there. It becomes a material that is less heterogeneous, but it's still not pure. And we need to provide more data on the composition there. And then we differentiate two different streams. So one stream is the clean loop recycling, where the material is collected in reverse vending machines, like bottles, if that exists in the country that you live in. And this actually the 3% that are in a closed loop recycling. The majority of material is still more curbside and very heterogeneous material that needs to be sorted further. And let's zoom into the waste sorting industry to see how we can provide more information to the value stream, but also provide more information to you to ensure that you reach the quality that is needed for our circular economy. So thinking about a sorting facility, or thinking about the digitalization of sorting facility, where do you need to start? So there's a lot of equipment in there, like conveyor belts, shredders, or any other equipment. It's not precisely the smartest equipment. So they are a lot of sensors, and if there are sensors, they provide data about the state of the machine. Unlike the optical sorters that can actually detect the material that they process, or they actually need to detect the material that they process. They use their machine vision to see every piece that's going through, and they define what kind of material this is composed of. So machines provide data on how the material is fed into the system, how it's spread across the belts, what is the composition based on the machine vision that the machines have. And in the end, that is data based on the sorting system. So it's not a quality analyzing system, right? But why shouldn't we use the sensors that we already have and adapt the sensors to our needs? So these are sensors that can shed light into the current black box of a sorting facility. But what are now the benefits, or what are the tangible benefits of having all that data in your hands? So we defined 4 opportunities where you can link all or more detailed opportunities. Starting in the top right corner, reducing downtime, so actually improving the availability, understanding how your plant is running, and understanding the machines. So the optical sorters is one of the core parts of your sorting facility. Really ensures that you understand the overall process, like what happens before your plant breaks down or stops, not exactly breaking down. Is it due to one of the optical sorters, or can we use the data that the optical sorters have to predict where a failure is happening? Can we predict a blockage on one of the conveyors? Can we see that one of the wind sifters is not sucking up the material anymore and they have too much 2D material in the 3D fraction? But that's too technical now. Going to the next one, maximizing throughput. So really improving the performance of the plant, ensuring that you can run the throughput that you desire to run and achieve the quality at the end that you need. So it starts from how is the material fed to the plant. Usually when we look at the data of our customers, we see a lot of fluctuation. It's not what you would think of as a homogeneous infeed. It's actually a lot of fluctuation. It looks a bit like a wave. And additionally, it's how the material is spread across belt. So we use optical sensors and we look from the top of the material. If you can imagine that the material is overlapping, we cannot detect it. And we need to ensure that the material is distributed correctly. Now, the belts are running at approximately 3 meters per second. So if you stand next to these belts, you don't really see how the material distribution is and if this is correct or not. So you need to have this data from the machine and how the machine detects that. Third is reduction of operational costs. Actually improving the efficiency on running the systems. How can we reduce the effort that you need to put into to run your system at the most up to the most potential? And last but not least, the quality. It's a really important topic, and each and every customer has their specific target quality for each material that they need to provide to their suppliers. And up until now, it's a lot of manual work to ensure that quality, and there is no solution to have that yet. But how can we monitor it better and see trends and see when the quality is changing and reducing the manual effort? Let's talk about 2 specific use cases that we are working on with customers. Starting with the first one, the performance monitoring. So let's put ourselves in the shoes of a plant manager. Possibly you are one, and in your daily business, your task is to maximize the utilization of your assets. So ensuring that you run as many tons as material through your plant, or in reaching the best quality that you need to, in the end, it's all economic value that you need to reach. So, but up until now, most of the plant managers depend on their gut feeling. So the experience of 10, 20, or 30 years in the industry where they know how to run a plant like that to achieve the performance and quality that they desire. But are we sure that this is the maximum potential that you get out of it? What if you combine your gut feeling with data from the machines right into your hand? Imagine you have a performance report every day when you come into your plant and see what has happened in the last 24 hours. And here, for example, you need to combine different point of views. So the first statistic shows you the amount of material detected by the machine, which looks very stable. So you might think, okay, we ran with approximately with an average of 20 tons for that day. Everything looks good, and it should be all fine. But if you combine this with the second statistics, the material distribution across the belt, they can actually see that at some point the material started to bunch together on the left side. And as I mentioned before, if the material is overlapping, you're not sorting as good anymore. And if this potentially is the first machine, this has an impact on the whole cascade of your sorting process. You need to consider that and not just reduce it to the amount of tons that you process, potentially if you need to reach a specific quality. Another important topic that I've already talked about is quality. So let's talk about quality monitoring. And as I mentioned, it's a lot of manual effort today. So usually a quality manager in his daily work today, they take 10 to 20 kilogram samples several times a day, count it by hand, and predict the quality of the remaining ton batch. And if you're part of the industry, know this is a very heterogeneous material. And for those who are not familiar with the industry, Imagine your yellow bin, yellow bag, or anything. You can't really say that you have the same waste as your neighbor, and so it's not always representative taking a 10 or 20 kilogram sample for a 1 ton batch or even more. So what our customers do that have the data in hand, they take this timestamp when they took a sample and combine it with what the machine saw during that time. So here in the quality report, you can see that the composition is changing. So there's kind of a stable composition with a bit of decreasing of some materials over time. And then all of a sudden, a lot of plastics is detected. There can be several different reasons for this. It could be that, well, there is plastics in that material. It could be that there's something stuck on the machine, and if it's stuck on the glass, you don't see anything below there anymore. There are possible reasons, and you need to understand what's the reason. So talk to the plant manager again. But what we can be sure of is that it has an influence on the sorting quality. So if you take a sample in that time, it's probably not representative of the time before or over the whole 24 hours. So combining that and having an understanding of what the machine detected during that time really provides you more insights on how to combine this data. So these are just two examples of how the data can help our customers ensure that they run this process at a perfect potential. But let's sum up. Let's sum up the benefits of digital connectivity. So first of all, it's designed to put you in control. It's designed to reduce the amount of gut feeling you need and combine it with data to really ensure that you maximize the potential. By monitoring the availability and performance of the machine, you have the tools to maximize the availability and performance. You have the tools to a better understanding. You first need to start with the transparency. So again, walk, run, jump, visualize, stabilize, optimize. You need to start with this visualization step. And by understanding what happens with the machines, with the optical sorters, depending on the conditions, it also provides you more information on maintenance needed. And we are already working on providing you more features on simplifying the maintenance to really reduce the effort on your side and reduce the time that we need to get the machine running at a perfect speed again. But as I've mentioned several times, the quality is important. And up until now, there is no simple way to have the quantitative quality of it, but we still already have sensors in the plants to see quality trends and provide these quality trends to the quality managers to reduce the effort to monitor the quality and ensure that we have a continuous quality reaching the value chain for circular economy. And last but not least, the collaborative expertise. So having data in your hand, you have the possibility to improve your processes by yourselves, but you can also share that data. You could share it with your suppliers to define what material they sent to you, that there has been a change and this impacted your performance. You can share the data with your customers to reduce the effort of the quality process on their side, but also collaborate with us as suppliers of the optical sorter systems to ensure you have to find perfect potential and to improve the system continuously. So reference back to the journey of digital transformation. I mentioned that we started several years ago, that we started with the visualization step. We actually started in 2018. And since during the last 3 years, we have continuously developed this system. And currently we have more than 220 machines connected and many active users on customer sites. And with that, we would like to invite you to start that journey. If you think that digitalization is really important to you, start with the visualization step. Start with having the data that the sensors in your plant already have, having those in your hand and seeing the potential or the possibilities that you have there. So thank you very much. And with that, I give the word back to Michelle.
Share the web.
Michelle?
I'm here, almost.
We can't see you yet.
Yeah. As you see, we are live. Give us a second. You still don't see me, right?
No, but Philip is here now.
Okay, then I continue talking. Thank you very much, Johannes, for explaining how digital connectivity contributes to enabling a more circular waste management approach in boosting recovery rates, and which role TOMRA Insight, our all-seeing eye of the plant, plays. But what I see here is that your presentations triggered a lot of questions. So our question inbox is full. And if you are ready, we can switch over to the Q&A session.
Yep.
Very good. So the first question is for you, Philip. Do you have any more examples showing what the machine can do?
What we see is, so in the developing phase of AutoSort, first of all, we start more or less in our test center to test the unit with different amount of material, different segments. And here we saw that we can improve a lot of applications. What you saw in MASOTINA, so here, this is the packaging area, more or less the PET area, which we could improve. What we could also improve is on MASOTINA side, we could create a new material stream from the specifications of Corepla. It's called VPET. This is bottle versus tray, where we sort out all trays together, so all multi-layers and all mono-layers together. And what we can also say is we have a plant in Germany which is sorting paper, so the inking, with Mr. Koppitz. And here we could also improve the sorting results. So we had an upgrade from AutoSort 4 to AutoSort 5. And here we could improve the recovery and also the purity from paper from 92 up to 95, 96%.
Oh, these are good results. And you already mentioned PT, multi-layer sorting and recycling. I have a question here asking, is it possible to separate multi-layer from monolayer PET packaging? Can you further explain this?
Yeah, it's not so easy, these questions. So basically it's possible to sort multi-layers, but there are, let's say, if you talk about multi-layers, there are several multi-layers bottles on the market, and it depends on the structure of these bottles and of the features of these bottles, or if it's the transparency of the material. And what I said on the structure of the material, how thick are the different layers of the multi-layer. We can detect these as a multi-layer, or if it's too thin, then it's challenging for us. But here in that case, if the customer is interested into that, we can test these specific bottles in our test center, in one of our test centers, to be sure that we can solve this problem.
Well, that's an unbeatable offer. I directly have another question related to this for you, Johannes, stating, can we test TOMRA Insight?
Great question. Absolutely, you can test TOMRA Insight. So for us, we understand that it's a complete new topic for us as well as our customers. So we've gained some experience there, but we see that it's still new, and we would invite our customers to this journey without asking for too much risk. So you can test TOMRA Insight for the first few months for free, and reach out to us, so our sales guys or our service, wherever you're closest to, and we'll set up a meeting talking about the possibilities. Absolutely possible to test it.
Thank you very much. But I directly have another one for you. Do I have a disadvantage when I start using TOMRA Insight as an early adopter? And is it upgradable at a later stage?
Mm-hmm. Yeah, again, it's a great question. Being an early adopter has advantages and disadvantages. In my opinion, the advantages are more important if it fits your mindset. So you have the possibility to engage with us closely, to impact the journey that we take. So we develop this very closely with our customers and gather the feedback from our customers and take this directly into our development process. And linking this to the second part of the question, TOMRA Insight is well, it sounds a bit weird. It's not a finished product, but it never will be a finished product because it's a continuous process. We continuously develop this product or this service in an agile way. So in 3-week sprint cycles, we release new features or completely new epics to all of our customers. So it's autonomously updated. And with that, I don't see much disadvantage of being an early adopter. But it should fit your mindset. So you should be willing to engage actively with us and making sure that we build this solution for the circular economy.
Thank you very much for being this transparent. I hope this clarified the question. Philip, is it possible? Oh, no, sorry. What is the smallest size of object that can be recognized by the AutoSort?
Smallest object size. So we have now the possibility with the AutoSort to sort also very small objects with our X ultra high resolution. So we're talking about 2 millimeters. So we can sort with the AutoSort, let's say flake objects, and we have also now the valve block available, which are precise enough to go into this sorting.
Thank you. How is digital connectivity carried out in practice? What additional devices or equipment will be required? Yes, this for you, Johannes.
Yeah, I would say it's for me. So how do we connect the machines to TOMRA Insight? So something that we did not state until now, TOMRA Insight is a cloud-based solution. So we need to connect the machines to the internet, to this Microsoft Azure cloud that we host. So we will install an additional computer at your site, connect all machines to a specific computer that's triggering the machines to send out data to the computer. And when from there on, it's going to be encrypted and sent out to the cloud again. So in the end, it's just one small additional hardware kit that we need, and the whole process of getting the data from the machine to the cloud in a safe manner, and also ensuring that the data is safe in the cloud, it's all something that we take care of, and that you can lean back and have the data in your hand.
Speaking of safety, someone asked how safe it is to use TOMRA Insight.
Yep, data privacy is a common topic, and it's a very important topic. We are very confident that it's very safe in Microsoft hands. So we rely on Microsoft and the Microsoft Azure solution, since it's a very trusted system. So we host all our data in Microsoft 365. Our data is already on an Azure cloud, and most of our customers do the same as well. But we don't just simply trust Microsoft. We also do third-party penetration tests on a regular basis, ensuring that everything is risk-free. So we are absolutely confident that it's safe, and see this as the only solution to really share data between each other, and take every measure to make it as safe and private as possible, that your data is your data and you decide who you share it with.
Very good. I hope we could reassure our participant asking the question. Can data from other non-TOMRA companies aggregates also be integrated into TOMRA Insight?
Again, a question that I've heard several times during the time that we've worked with this. Up until now, we focused on TOMRA equipment. We connect the TOMRA equipment where we see the necessity to combine it with other parts. So we are working on this, and we will reach out to the market as soon as we have a solution for this. But up until now, we focus on the TOMRA sensors, and we are confident that we already provide a lot of value by showing what data our sensors provide to you.
Okay, now I will shift back to Philip, give you some rest. Philip, can you or we distinguish between HDPE and LDPE objects of the same shape?
Yeah. So here we have several sensors which we can go and analyze these materials. So PE, HD, LLD or LD. So this is possible to separate these objects, of course. Yeah.
Okay. Do we also foresee marking techniques like UV marker or watermarks in packaging in the near future?
So we are, let's say with TOMRA, we are working in several projects, and we provide here our knowledge and also our sensors. So there's something ongoing, and this is more or less what I can say.
Thank you very much. You mentioned before about autosort lasers sorting black plastics. Mm-hmm. Can you explain a little bit more about it and how far this is possible?
Yeah, sure. Will be a little bit technical, though. Standard, let's call it standard autosort, where you have the NIR technology. This has some limits if you have some black polymers which are carbon inside, because you don't get feedback back from the material. So the autosort cannot recognize that. This is why we add an additional sensor to that. This is the deep laser, and now it's possible to recognize these objects, and then we can sort it. Let's say positive, let's say as an impurity or as a wanted fraction. But that doesn't mean that we can sort these black object via type. Therefore, we have other solution, and this is not the, let's say, the autosort.
Thank you. I have one last question for you, also for you, Philip. In MSW sorting, how defined can we sort, or how small can we sort with our equipment? How detailed can we be, or accurate?
Mm-hmm. That's depending on, let's say, the sorting steps and the accuracy you need. So MSW means, first of all, you recover out of these MSW streams the polymers, the wanted fractions. So first of all, first step is high recovery, because you don't want to generate losses. Then you have a concentrate of material, which is also similar, let's say, like packaging, PP, PE, LD, HD, PET, PS. And then that comes to, let's say, we call it the cleaning steps, where you need several optical sorters to clean these products to your needs, more or less, to the accuracy you need.
So for
Thank
you,
you very
for you who don't know MSW, it's municipal solid waste. So anything that's not packaging.
Yeah, that's true.
Very good. Thank you very much. Given the time, so we already exceeded the time a bit, I would like to close the Q&A session now. But since our inbox here is still full, which is bringing a lot of homework for us, because we are going to answer the remaining questions and share it with you as soon as we can. As announced in the beginning, once we close this window, a short survey will pop up, and we would highly appreciate if you could take 1 minute more to give us feedback, which will help us to make future webinar experience, which I'm sure will come better and more adapted to your needs. So from my side, thanks again for the presenters, Johannes and Philip, to the entire organization team, and for you all joining. We have always been more than 350 participants, which is really amazing. And this being said, I'm closing the session here and wish you a great day, and ciao.